So we are going to start our next part of the lab 2. Now this part is extremely important for us to understand. Now think about all this number system. The reason we actually started with the number system in this class because all the digital devices including computer actually use the binary number system. Okay, so binary number system has a very strong connection with the digital circuit. So we'll probably know these very soon once we start working on the digital circuit. But as you have seen in the binary numbers is completely a different way of representing the numbers. But I'm not sure whether you have thought about this, that how do you represent the negative numbers in binary? You might think we can just put a sign, negative sign at the beginning of the number, but how do you put that sign in computer? Because in computer, in any digital device, everything is represented in terms of binary, meaning 0 and 1. So everything is just 0 or 1. There is no sign. There is no way you can just put a sign in front of a number. Okay? So that's why in computer, by default, every number is a sign number, and there is a very unique way of representing the sign number. Okay? Which is very interesting. So in this part of the lab, we'll actually look at how do you represent the binary numbers as signed binary numbers. Okay? So I tried to write a couple of things, but here the main idea is the very leftmost bit of a number actually represents the sign. So for an example, let's take a look at this binary number. Okay, this is sign number. By default, any number you have in your computer, by default the most significant bit, which is at the very left side, is the sign bit. Now how it is a sign bit? If it is 0, that means the number is actually a positive number. If it is 1, that means number is actually a negative number. So the very leftmost bit is actually part of the sign. It's not part of the number. That just represents the sign. Okay. Now, to make it a little bit simple, what we do is we actually write every negative number as something called 2's complement form. Okay. We'll talk about this a little bit more detail soon, but as you see here, for an example, negative 58 is something in binary, but just by looking at the binary, you will never know this is negative 58. But if I tell you this is a sign number, since you know that leftmost bit is for sign, you can guess this might be a negative number. But you don't know how it is negative 58. But this part of the lab will actually tell you how to understand that sign part of the number. So let me quickly jump onto an example. Now, what happens in the negative number is this. Remember that when you talked about the binary number, we know that every position has a weight, right? And these were the weight, right? So let's go back here and look at the weight. Very rightmost one is what? Start from 1, right? And then weight get doubled every time, because this is 2 to the power 0, this is 2 to the power 1, right? Then that's 2 squared, 2 cubed, right? Remember those weights we started with when we talked about the binary numbers? But what happens is, by default in computer, very leftmost bit, for an example here in this case, very leftmost bit, which is this bit, the weight is actually negative. See, instead of having it 128, this is actually negative 128. That is how the idea of the negative numbers come into picture. Okay, but if you have this number written like 110001110, then just like how you convert any number, binary number, into decimal, if you do that, just look at the difference now, because this is negative 128 and this becomes a negative number, which is negative 58, because of the weight at the very leftmost bit is negative. You see what I'm saying? But if this bit is 0, then you do not care about this weight, right? You see what I'm saying? The number is always positive in that case. Okay, now in this part of the lab, which is lab 2B, what we'll do is we will give you a hex number in every question. For that hex number, you have to first write the binary, which is very easy. You already did that in the lab 1, right? And then for the binary, you will first write the unsigned decimal, which is also pretty similar, because this is exactly what we did in the first lab, where we converted from binary to decimal. Because at that time we did not talk about the sign, but in general, if you don't talk about the sign, that is called unsigned decimal. You see what I'm saying? So that's just the regular decimal, okay? And then we try to find out the signed decimal using an easy technique. I'll show you the technique, okay? Now, for an example, take a look at this question. The hex number which is given to us is 8A. In the first step, we'll convert the hex. We convert the hex to binary, which is pretty straight. Remember, we just look at the chart and do the conversion, right? The hex chart that we have. So what is A in chart? 1010. This is my A from the chart, okay? And 8 is 1000, okay? But I just want to make sure you see that this is the very leftmost bit is 1, right? That actually tells that if you convert this number as a signed decimal, this is going to be a negative number. Okay, now let's first do the unsigned conversion. Now unsigned conversion means just the same conversion we did for lab 1, okay? How do you convert it? Remember what we did was we just took the weight of the position where we have 1, right? Now the weight of this position was what? 2, right? This is how the weight starts. 1, then this is 2, this is what? 4, 8, 16, 32, 64, and 128. So look at this. I'm just taking the weight of only the positions where we have 1, right? That's exactly how we converted, right? Remember the very beginning? And then we add those 3 weights, because there are only 3 ones, to make it 138. Now this is our unsigned decimal, which is the regular decimal that we got in the lab 1, right? Now to get the signed decimal, this is how we do it. We subtract 256 from any number if the very leftmost bit of the number is 1. Now the leftmost digit is 1, okay? Be careful, look at this. If this is 1, then we subtract 256 to find the signed decimal. If this is 0, then the signed decimal and unsigned decimal are same. There is no change. So since this is 1 this time, I subtracted 256 to make it negative 118. So you might be wondering, how did I get this 256? What it is? This is exactly what happened. To make it simple, I actually did that, but the idea is this. Remember, in the signed decimal, this weight is negative, 128 is negative, right? But instead of, right, remember in the last slide we showed that this weight is negative, but instead of making it negative, we just made it positive, right? How do you adjust it? Now think about a small math. For example, you are doing a small math, okay? And you added 5 instead of subtracting 5, but you should be subtracting 5, right? But you added 5 by mistake. How do you fix it? You subtract 10, right? That's what I'm saying? Do you understand what I'm saying? So let's say you actually are supposed to subtract 5, but by mistake you added 5. How do you fix it? You are supposed to subtract 5 from something, right? But you added 5. To fix it, you actually subtract 10, right? You subtract double, right? Because you added 5 instead of subtracting 5, now you're fixing it, so you actually subtract 10. That's exactly what we are doing. Because this should be negative, but this is positive here. To adjust it, we subtracted 256, which is double of 128. I'm saying a simple idea, okay? But remember, this subtraction is only valid if you have a 1 here. Say it again. Oh, I got 138 from here, right? Yeah. So every question is just like this one. You'll be given a hex number and you have to write 3 different answers. One is, the first answer is a binary number. Second answer is an unsigned decimal. Third answer is a signed decimal. And remember, signed and unsigned decimal will be same if the binary number starts with a 0 at the left side. Because in that case, there will be no subtraction. Okay? So, and all these 3 answers you'll be writing in the same line, just putting a space between the numbers. We actually mentioned it in the question. So let's go to the lab 2B and let's try a couple of questions here, and this is going to be the last part of the lab 2 we'll be working on today. Okay? And then we'll complete the remaining part of the lab 2 next class. Okay, so once you finish this part, make sure you submit it, and just like any other lab, you can try it again if you don't get 100%. Okay.